last guest speaker tonight is Professor Tony Haymet. He is co-owner of a company called MRV Systems, Distinguished Professor of Oceanography and Emeritus Director and Vice Chancellor for Marine Sciences at Scripps Institution of Oceanography at the University of California, San Diego in the United States.
If I was a braver person, I would say what I'm really famous for is that 300 years ago I was Erica's PhD advisor. But I don't think I'm that brave. I want to tell you about this little robot. This robot was developed over about 3 decades. It really incorporates the work of a huge number of engineers and scientists and electrical engineers, but really was the vision of one man, a guy called Russ Davis. And the company that I bought with my business partners is one of 3 or 4 companies around the world that makes this little robot. And it's just a little submarine. It's about 2 meters high. It sinks itself into the ocean down to about 2 kilometers. It drifts around for 10 days, and then on the way up it measures scientific properties using the sensors, as Dr. Moore told you about. The simplest version measures temperature and salinity. And when it gets to the surface, it reports back that data through the satellite network, or these days through the Iridium telephone network, back to a lab. It happens to be a lab in my institution, and then freely to everybody around the world. Now, you might wonder, why you want to do that experiment. First of all, let me say that yesterday there were 3,881 of them operating, made by all the different companies. 23 different countries, including Australia, have funded these little robots. And, of course, what they do is measure the heat that's moving around in the ocean. And it's no accident, I think, tonight that you're hearing from Professor Chubb and in the speakers tonight a lot about the ocean, because 71% of planet Earth is ocean. It's actually quite hard to go out there and do experiments. And for hundreds of years, oceanographers and chemists have known that we ought to go out there and measure what's happening with the heat and the currents and the salinity and the CO2 that dissolves in the ocean and changes the acidity, but also other kinds of things. What's the DNA of the organisms that live in the ocean? The trouble is that no taxpayer in their right mind would fund us to go out in ships and lower enough thermometers into the ocean to really profile the ocean temperature the way that we need to do. So this is what I love about science and engineering. The kind of individuals that put their life on the line to make a little robot like this. So when my friend Russ started doing this, everybody laughed at him, but everyone had different reasons for laughing at him. First of all, batteries were hopeless. There were no mobile phones. So when Russ made his first version, it lasted about a week in the ocean, and then it died because there were terrible batteries. Well, now they last 5 or 6 years. In fact, the ones that we make, they fail for other reasons. The sensors wear out, or they get clogged with slime in the ocean. The batteries are still ticking. The second thing is, when Russ started, there was no satellite network, so there was no way to get the data back to the lab, and everyone thought he was crazy. But Russ thought, he'd just heard about Sputnik and, the Russians and the Soviets, and he figured eventually there'd be a satellite network. And so he just set about designing the best little submarine that he could, using the minimum amount of energy to make it go up and down in the water. Along the way, he accumulated all kinds of partners who could do the electronics, make it robust, people that design sensors that last not, like a pH sensor that we use in the lab that has to be recalibrated in the morning to the afternoon, but to last for 5 or 6 years in the ocean. Now, this experiment's called the Argo experiment. How many of you have heard of this experiment? There's a couple of people. Professor Chubb's heard of it. That's a relief. Well, this experiment does lots of nifty things. First of all, the weather that we experience here in Armidale and throughout Australia is really determined by what's happening in the ocean about a month ago. So by measuring all the currents and the heat patterns that happen both in the Pacific Ocean but also in the Indian Ocean, we're able to figure out a lot about the kind of, statistically, the weather patterns that are about to happen in Australia over the next month. More importantly, the information we need to know about what the average rainfall is going to be 10 years from now, 20 years from now, 30 years from now, that's entirely determined by the ocean. It has almost nothing to do with the atmosphere. 73% of the heat that we make as human beings is dissolved in the ocean. Now, this could have been the most famous experiment in the world, and you would all know about it. And that's because it was an experiment designed to prove or disprove global warming. You probably know the story, and actually my institution, the Scripps Institution of Oceanography, started the measurements of CO2 in the atmosphere in 1958, a man called Charles David Keeling, and we've done it every month since 1958, not without some trouble in raising money, as I found out when I became director. But that gas, if you've done vibrational spectroscopy, a plug for physical chemistry here at the University of Armidale, that traps heat, and that heat has to go somewhere. It can't stay in the atmosphere because it's connected to the ocean, and so 93% of that heat is transmitted into the ocean. So if you measure the temperature gradient of the heat in the ocean on average, if you don't measure exactly the right amount of heat, it's not just measuring any amount of heat, it has to be precisely the amount of heat that's going to be trapped by CO2 and methane and all the other greenhouse gases. If you get that number wrong, that's an experiment that disproves the current hypothesis of global warming. Well, the reason that you don't know about this experiment is, of course, it was an experiment that confirmed or led weight to the currently accepted understanding of global warming. But that's what science is. You go around trying to create precisely determined experiments that will tell you a yes or no answer. If you confirm the sort of currently understood wisdom, you might be a footnote in the history of global warming, although this experiment happens to be more important than that. If you, of course, disprove global warming, then you're the most famous scientist in the world, and you never know. There's always a tiny little chance that it might happen. So this is how these robots work. Up until recently, we've had to drop them off the side of a ship. So we have to find somebody that's going in roughly the place where we want the robots to end up. That's pretty easy to do in the Northern Hemisphere because these can be dropped off cruise liners, and there's always ships going between Singapore and Los Angeles and so on. It's been a real pain in the neck in Australia. So when I was working for CSIRO in Hobart, we had all kinds of trouble finding enough ships in the Southern Hemisphere. And so when I and my business partners bought this company, we decided to make an air-launchable version of this robot. So now we have one that's a little bit smaller, that fits through a standard-size hole that a lot of research aircraft have, and has a little parachute, and you stuff it down the hole and hope for the best and watch the little parachute open. And if you connect with me on Twitter, I can send you to a little movie of this. So that was a little indulgence that I made the company make, really, because I'm Australian originally, and we really needed it for the research in Australia. Once we'd made this product available, all kinds of people came up with uses that we couldn't possibly have imagined. So all the people that trace cyclones and hurricanes want to deliver their instruments into the very center of the cyclone or hurricane or typhoon. And they'd always tried to do it by, setting up 6 copies of their instrument in the ocean and hope that the hurricane went, right over the middle of the instrument pack. Of course, hurricanes being what they are, they always go slightly left or right. And so they would fly their hurricane-chasing aircraft right through the middle and drop off the instrument pack right in the middle. And our parachutes were tough enough that they survived the drop in winds that are quite a few hundreds of kilometres per hour. Other people have discovered other uses for these things. So the little top of the robot has a capacity of about 1.2 kilograms, and there's a certain amount of battery power that we have. So we're able to go to people like Dr. Bergara and others who have sensors, who want to measure various things in the ocean and maybe listen. We have a version of this robot that lies on the bottom of the ocean until a particular whale goes by. So my colleague John Hildebrand is able to, through his knowledge of acoustics, is able to identify a particular whale, John or Mary or Fred, And the little robot will lie there until the whale goes past, and then it'll pop up to the ocean and say, "Hello, I just heard Fred go by. You know, it was going at 2.5 knots, and he was heading south-southeast and heading to Mexico, and his favourite breeding ground." So there's really no end to the sensors that people are inventing. And, you know, practically every week someone in the lab will show me a little box they've designed that uses hardly any power and is light enough to be able to put in these robots. I mention this because quite late in life I came to the idea that I would buy this company. It's a thing that I encourage you to do. It takes a little bit of courage, and I have to say I wish I'd done it earlier in my life. Lucky enough being in CSIRO and then to work at Scripps that we started a lot of companies, but my role was more of encouraging the scientists to put together the idea and then going out and finding the investors. Well, it turned out right in the middle of the global financial crisis, that was really the North American and European financial crisis, that we tried to start this company and the investors weren't particularly great. So when I retired as director, we decided we'd buy the company and get out all of the new products that we'd imagined all those years ago. At the moment, I'm in Australia trying to start a company connected to algae and aquaculture. And again, these are things that I've learned a little bit from my own research, but mostly by just talking to scientists and working at CSIRO and trying to pay attention to people that maybe were a bit outside my field, but you know had that spark, like the people that you've heard tonight. People doing interesting things that were going to really have an impact on planet Earth. So I was lucky enough to have a group in CSIRO of people that learned how to grow fish, but grow fish very cleanly, so without making pollution. In fact, my friend Nigel Preston had a big tank in our lab in Brisbane, in the suburb of Cleveland, where the lab used to be, and no water left this tank. A little bit of water would evaporate from it, but in this tank were prawns that were growing, and prawns, you know, eat a lot and also have refuse, like our engineering friend was talking about. But Nigel had figured out a way to take that refuse and combine it with something else and turn it into food via algae, or algae as we say in Australia. So this is like a closed system that's just making, you know, black tiger shrimp or Panaeus monodon, this very nice kind of prawn that we have in Australia. So, you know, I'm really one that likes to count our blessings. And I think if you're lucky enough to come to Australia or be educated in Australia or be born in Australia, I think we've each been handed a gift. And there's other people here that are like honorary Australians in my view. And the trouble with that gift is it sort of peaks when you're about at the end of your undergraduate degree. I think we have a fantastic education system. You know, we all roam around and complain how it wasn't as good as it was in our day 300 years ago. But it's awfully good. And I've been lucky enough to work in quite a few different countries and sit on review panels in different parts of Europe and so on. You know, I think when I started at Lane Cove Primary School and went through high school and went to uni at Sydney, by the time I was 21, I had the most fantastic education for doing engineering or science or maths. And then I went overseas to do a PhD, and it took me a while to realise that I knew more than anybody else in the class. That was my first great realisation. The second thing is, it took me a little bit long to realise that a lot of them were a heck of a lot smarter than I was, and within a year or two they'd caught up everything that my Australian advantage had given me and more, and were way far ahead. So I think, you know, count your blessings, be glad that you've been educated in Australia. I know I am every week that I work in this business. But recognise that other people out there, even though they may not have that advantage of being in Australia and having our high school system and our uni system, somehow they muddle their way through. They do ceramics and drama, and they go through being actresses, but then when they get to be scientists, they catch up really, really quickly. So count our blessings, but recognize that it only lasts for a little while, and you have to use it. The other thing is we've all been blessed with, this Australian larrikin business, which is incredibly valuable in science. I have colleagues around the world that say, please send me more Erica Smiths. People that have absolutely no respect for my ideas. And will tell me straight to my face that I'm full of it. I can't tell you, that's the greatest thing in science, And somehow, there's a little bit of Nick Kyrgios in all of us. Hopefully a tiny little bit. Or, a bit of Dawn Fraser, or heaven forbid, Shane Warne, where you just don't go along with the flow. And of course, that's what discovering new things is all about. If you just agreed with, what your lecturer said or what your professor said, nothing new would ever happen. Somehow you have to be able to say, it doesn't necessarily being right. Half the time that Erica complained in my group, she was wrong, but she would still speak up, and is still speaking up today. And that's the other gift that you're given as an Australian. And so my message to you is, don't waste it and have fun. Thank you very much.